talk about first, who am I? My name is Philip Tellis. I work at Yahoo. That's my website, bluesmoon.info, and on Twitter I'm at bluesmoon. I've been an open source developer for about 10 years now, working on completely different things. And what I'm going to talk about is find out what makes a website slow, what do you do to make it faster, list some known tools, and show off some pretty pictures from Twitter. Right? So I hope one or more of those are useful for some people. So, what is a website made of? You have content, which is typically HTML, images, and Flash. Some of the images in Flash may be used for style as well, decorations. Then you have style sheets, interaction built with JavaScript, maybe some other scripting language. All of this runs probably on a server farm. Some people have one server, some have many servers distributed geographically. And maybe you have a database, maybe you have flat files, maybe you get all your data from web services, and you probably use a CDN to distribute it geographically. Right? So now looking at this, where do we think the time goes when a user comes to your website? What happens between the user typing in your URL in their browser and the page actually loading up and the user thinking it's ready to be used? So first of all, the browser uses the system's resolver to do some DNS lookups, then makes HTTP requests. Once that request gets to the backend, the server has to build a page. So that may involve a whole bunch of things, including getting data from a database, pulling data from various web services, maybe checking if the user's logged in, etc. Once that's done, it's a lot of time spent in downloading stuff. So downloading the actual page, downloading style sheets, downloading JavaScript, downloading images, and anything else that you may have. Once all that data is on the browser still has to render it. So then it spends a bunch of time rendering it. And then there's user interaction. So the page may be ready to use, but it may be an interactive page, so there's some time spent in user interaction. And that's also included in what the user thinks the performance of your page is. Right? So how do we actually fix all of these? And we can fix each of these parts separately to get some amount of boost. So if we look back, we see we have a lot of lookups. So by reducing the number of lookups and connections, we can get some amount of performance boost to speed up building up pages, return content as fast as possible. And we'll see how to do that in a bit. Reduce the size of content, obviously. Reducing the size of content, in turn, reduces the amount of time it takes to download that content. Restructure your pages to be performant. So there's some browsers render pages depending on how the page is actually structured. By restructuring a page, you can actually make it render faster than otherwise. And you can always cheat. Nothing else works. Even if everything else works, you can still cheat. So how do we reduce lookups? The first thing we can do is reduce the number of domains. So based on how many domains you have on your page, the browser needs to do that many DNS lookups. Okay? So if you reduce domains, if you have just one domain, it needs to do just a single DNS lookup. You have two domains, as you have more, it goes up, and the time it takes to do these lookups increases linearly. So keep that number small, not too small. We'll see why later. Second, you want to avoid redirects. So every time you do a redirect, the browser needs to open a new connection, possibly do a new DNS lookup. So you want to avoid redirects. If your content or your resources are available on a particular server, always use the canonical name of that server. So there's differences. You might have like a load balancer that sits in front of your servers. In that case, always point to the load balancer. Just make sure the users never redirect it from there. Right? Combine CSS and JavaScript files into a single file for each type. So there are many sites that have, let's say, 3 or 4 CSS files. Right? One file that they use across all their pages, one file that's specific to maybe a subsection of the site, and one file that's specific to that page. That means 3 downloads. Right? Instead, if you combine that into a single file, you have just a single download. The same thing with JavaScript. Right? Let's say you use the YUI library. Okay, that's something I'm familiar with. You want to use something like animation. That means you need to get Yahoo.js, DOM.js, event.js, and animation.js. Instead, you can combine all those 4 into a single. You get just 1 download rather than 4 downloads. And the YUI library allows you to do that automatically. But if you need to do that for your own JavaScript files, this is a very simple combo handler that I just hacked up about half an hour before this talk, actually. Actually, I hacked it up on an airplane when I didn't have access to the net. But it's not security checked. What it does is just picks out the URL, splits on ampersand. So you have multiple files separated by ampersand, and then looks for all those files on the file system and just does an include on them. So it's PHP code. This does an include where www.source, where source is each file. So it's yep.
Have you done benchmarks across like using the multiple files and combining them into one versus having them split out? Because I've seen results where when there's more files that are smaller, you know, my page loads faster.
So it depends again on how your page is organized, on whether those files are cached, and what the combined size works out to, and how many files you have. So there's a lot of variables. You can do a lot of testing if you have the time and expertise to do that. If you don't, a good rule is always combine files. Right? HTTP connections tend to take up a very large chunk of the time to download. So combining JavaScript into one file can save you a lot of time. Sometimes combining into 2 files, one that you load at the start of the page and one at the end of the page, can buy you something over just a single file. So you may also have a lot of decorative images on your page, rounded corners, colored bullet points, I don't know what else, icons. You can always combine these all into a single image sprite, or maybe 2 image sprites, depending on the number of colors you have in each and whether you need to organize them horizontally, vertically, etc. So there are several tools on the net to actually combine images into sprites. I haven't listed any, but you can just do a search on CSS sprites to actually find some tools. And finally, cache aggressively. So the more content you cache on the browser, the less content the browser has to download from your servers. And I think another speaker spoke about this yesterday on how to actually do caching. So in Apache, I do something just like this. Set expires active on and expires default access plus 1 year, which means this particular page or any page under that /static location will always be cached for 1 year. Now, why do I say 1 year? The HTTP 1.1 spec actually states that no resource should be cached. The expires header should never state any date that's more than 1 year from the date of access, so that's why 1 year is the maximum. You could actually set it to 10 years, 20 years, 100 years. Probably doesn't matter because chances are you won't be using the same resource in 10 years. Next, be quick on the return. So we want to return data as fast as possible to the user. So that well, there are several reasons for that. The first of all is so that the browser can start rendering it as fast as possible. We want to get the first chunk of bytes out as soon as possible. So now, the first chunk of bytes may not actually be content. They may simply be the header, saying, okay, this is an HTML document. Now, the faster you know that, the faster you can send that out. And the reason for this is something called PCP Slow Start. Okay, so the way PCP works is now whenever a TCP connection is open and data needs to be passed through, the sender will send data based on a particular rate. Every time it gets an acknowledgement, it'll increase the rate that it sends out. And it'll keep doing this until a predefined limit or until it stops getting acknowledgements. And that's basically done to avoid saturating the network. Now, if you don't send the first byte out fast, what happens is there's no acknowledgement needed to come back. So this window keeps getting smaller and smaller. And eventually, you're basically sending out less data, or rather you're sending out data slower than your network can actually handle. So to avoid that, get the first byte out as fast as possible, which could just be doc type. Right? If you can send that first line out as fast as possible, that's good enough. Could be a header that you need. The problem is many times you want to send out a header that says 4030 403 or 401 or something like that, or some other kind of header, which you need to process the whole page for that. So if you can avoid that, that's always good. Flush often. So most backend programming languages allow you to flush content to the server, or rather to the browser, while it's still being processed. So you don't have to wait till the end of the page load. If you flush often, the browser has a chance to get data and start processing that data. So let's say you have your CSS, you already know what CSS you need for that page. Flush that, the browser can start downloading the CSS in parallel while you're still processing the rest of the page, right? So that also speeds things up a bit.
How does that work if you're gzipping?
Chunk gzipping, right? It works, so again, there's a trade-off there. So you may want to gzip fully and not send this in chunks. Or you may want to just send out the header once and then send the rest of the body gzipped. Yeah.
Doesn't the browser have to download the markup before it starts making requests for other media types?
So that's why I said, so if you send out the header, the head portion, which contains links to the CSS, then the browser can start loading the CSS, even though you're not completed.
Oh, I thought it has to get the entire markup before it starts making...
It needs to get the markup, but I can start rendering it at that point.
Okay.
But it doesn't need to wait to download it. There are other things like images, which may be inline in your HTML page that obviously needs the HTML before it can get that.
How do you do this in the change the body?
Sorry, I didn't get it.
How do you send out the first channel files in practice? Did you change the patch server?
Yeah, so I mean it's more with your language actually. So you can send the first chunk just by doing a flush, right? Or you have a header, you set a header and then do a flush, and that will flush it to your over the network. I mean, other languages may have other constructs. In PHP, called flush. Don't bother your server with static content. So you have an Apache server which is really built for doing a lot of dynamic stuff. It has modules to handle various content types. You don't really want it to be just serving an image that's not changing at all. What you can do is hand that off to a different server process or a different machine completely that actually specializes in handling static files. A CDN is something that can do that for you much better than you can probably do it on your own. Cache expensive backend calls. So if you call out to a database or a web service and the data doesn't change very often, then you can cache that content in memcache or some other kind of cache that you maintain on your web server itself. That does make your data a little stale, but depending on what your use case is, you can tweak that. So even caching things for 1 second or 5 seconds can buy you a lot on a really heavily trafficked site. And reduce max clients in Apache. So this is something that on the exceptional performance mailing list, we see some people have really high max clients and they see problems. So what happens really is, let's say you have max clients set to 300. And you have 300 users come in. They make the HTTP connections, but your server cannot handle all 300 connections. So what it does is it handles the ones it can, but all those other users that have already opened a socket are now just waiting for the process to actually do something. While they're waiting, they get fed up, hit cancel and reload. Okay. So now instead of 300, you've got 600 connections, some of which are waiting, and that keeps building up until let's say a server suddenly ready to handle it, and now it's got these 3,000 connections that are waiting to connect. Right? Instead, if you set it to something like 30, then after 30, users who come in will straight away get a request denied or something. So then they might retry, but it's not going to hold up your server, right? And your server will be able to respond when it actually has the chance. Finally, we want to slim down content to reduce the time it takes to download. So gzipping content over the wire, you can use something like mod gzip or mod deflate to actually compress the content while sending it from the server to the browser. That gets you huge savings. Minifies CSS in JavaScript. So by taking out white space comments and reducing variable names, there are various tools to again do minification of CSS in JavaScript. We use the YY compressor, but I'm sure you'll find other tools out there. You can also optimize images. So most images have a lot of information in them that's not visible to users. There's EXIF information in JPEG files that may or may not be useful to your users. You can strip that out. There's some kinds of alpha layers in PNGs that are not necessarily useful, so you can strip them out as well. There's a tool called Smush It that's at http://smush.it that can help compress these files for you. It does lossless compression of files. So you give it a list of images, it can take out all unnecessary information. Avoid duplicate CSS and JavaScript files. So if you have duplicate CSS and JavaScript files, some browsers, most notably Internet Explorer, will download them twice. Right? So avoid that. They will also execute and try to parse them twice. And it really doesn't buy you anything, so avoid that. Reduce cookie size. You can also do this by having cookieless domains. So move some of your content to a different domain that doesn't actually receive the cookies. And that can reduce the total amount of network traffic. Use a CDN to get your content geographically closer to your users. So the fewer network hops they have to go over to get to your content, the faster it will be for the content to get to them. And post-load content. So there may be some components that are not visible on the page when the user first comes to it. It may be below the fold, or it may be in a div that's hidden at that point of time. Load those images after the onload has been called. Okay. Research shows that users think the page is usable once that spinner has stopped spinning. So even though everything may be on the page, if it hasn't stopped spinning, they may not actually interact with it. So if you load things after onload, that doesn't affect the spinner, and users will start using the page. Restructuring your pages, put CSS at the top. So the browser will render the page when it has all the CSS. If your CSS is not at the top, what happens is, let's say you put CSS at the bottom. Now it's rendered the page once, and it's got CSS. It suddenly realizes it has to re-render the whole page. So the page blanks out, and then it gets re-rendered. Instead, put the CSS at the top so that browser can download it as fast as possible and start rendering the page as fast as possible. Put the JavaScript at the bottom. The reason for this is page loading actually blocks when JavaScript is being downloaded and executed. The reason for that is something called document.write.ln, which can change the structure of the page while JavaScript is loading. Right? Now, because the page structure might change, the browser doesn't know whether it can actually render anything further until it's got all the JavaScript. So if you put that JavaScript right at the bottom of the page, it still doesn't know whether it can do anything more after that, but at least it's already rendered everything before that. So anything that blocks is blocking something that really is not going to load anything else. Avoid tables for layout. This is actually an old one. That if you have tables for layout, the page actually can't be laid out until the whole table has been loaded. So don't do that. There's better ways to do layout. Delay loading of invisible content. It's the same as the post-load thing I mentioned earlier. And reduce the number of HTML elements. So a simpler page actually renders faster than a more complex page. Cheating the DOM. If you need to attach events, let's say you have 300 text boxes or 300 buttons on a page. I'm not sure why. Let's say you do. Instead of attaching events to each and every one of them, attach a single event to the container of all these objects, and then just trap the event.target. Okay? The target will actually tell you which element was clicked on, even though it's fired on the container. And using that, you can find out what you want to fire the event on. Delay event attachment. So the same thing with invisible content. You do not need to attach events to elements that are not currently visible. You can attach them just before they become visible or after onload. Attaching events is something that's quite expensive. Iterating through DOM nodes is another thing that's expensive. So anything that operates on something like getElements by tag name, that's going to be expensive. Try and reduce that. Cache DOM elements and work on invisible elements. So if you can store a DOM element in a variable, you have an ID, get a reference to that, and operate on that reference as much as you can. Don't keep doing getElement by ID. Similarly, work on invisible elements. So anything that's not visible on the page will actually, you can operate on that faster than if it's visible on the page. Because the browser doesn't need to keep re-rendering it every time you change a single property. reduce iterations on DOM elements. They're really slow, so try to reduce the number of elements in an iteration and the number of times you iterate. Use more specific, semantically correct HTML tags. So an example is a nested structure like this, which has div, div, input, input, div, div. Right? I change that to something like that. It means if I do a get elements by tag name div on this, it returns 1, 2, 3 divs. If I do get elements by tag name ul and then iterate through children, that just gets me one element and then 2 children that I need to iterate on. So this is a simple case, but more complex cases will get you much more benefit. Use local copies of global variables. So now global variables are interesting in JavaScript. Global variable is actually a member of the window object, at least in your browser. So when you do a lookup on a global variable, it needs to look up the entire window object to find that particular property within it. Right? If you use a local copy, it doesn't have to do this kind of lookup, and that speeds things up. Of course, before you do any optimization of your code, profile your JavaScript. There's the YUI library has something called the YUI Profiler that you can use to profile your JavaScript code. Finally, preload expected content. This seems like the opposite of postload, but it's not exactly. What it means is if you expect something to show up on the next page that the user is going to visit, try and preload that. Okay? Examples could be CSS, images, anything that you expect. Let's say you expect the user to click on a link and it loads up a new page, that you can preload those things. Progressively enhance your pages so that content shows up before you actually got the style and events attached. Try to set empty post requests. So I don't think I have enough time to explain that. Basically, a post request results in two TCP packets, one for the header, one for the body. If you send an empty post request, so put all the content in the URL, that's just one TCP packet. The add import way to import CSS in IE works as the same as having your CSS at the bottom of the page. So avoid that, use a link instead. And avoid 404s and reduce iframes. Both of them, 404s are just a useless HTTP connection. Iframes tend to slow things down as you get too many. There's a tool called YSlow. Version 2 is coming soon. You can get it from developer.yahoo.com/yslow. That goes through most of the rules I've spoken about and gives you analysis. Closing notes, don't optimize prematurely. So profile your code, profile everything before you do that. Configuration is cheaper than development. You probably need to look at scalability as well as performance, so don't just stop at performance. And keep things simple. So, a bunch of people helped with this research. That's all of them there. Mostly from Yahoo, some ex-Yahoos there. And used a lot of photos here, so that's the last point I mentioned in my intro. That's what we're going to do. Thanks.
No, it might be best if we take questions.
Yeah, so we can take any questions outside.